All right, welcome everyone to the third session for Visum overview. And we'll cover today some topics on data management because if you're starting your models from scratch or bringing in data, the first thing you need is to generate networks, manage some matrix data, and do some other I/O. The format we'll cover over here, since you're all mostly Florida modelers or Cube users, we'll have a look at how to bring in some of the Cube data that you might have into Visum, how to generate a bunch of those networks using the shapefile interface and such, how to do some database I/O. Then we'll have a look at network batching, where we discuss text-based network import-export in Visum. Then we also have a look at matrix import export with the OMX format, CSV and such. Some other topics in the end would include sub-area focus as well as some interfaces with the ABMs. So with that, let's begin our first topic over here for external formats, where we look at cube imports. So external data import over here with Cube typically will end up working in this workflow where we'll first need the node shape link file and the PT lin file from Cube to be exported. This way Visum can understand that data, which is in more of a common shapefile format rather than the Cube binaries. Then we can use the Cube import add-in specifically developed for Cube to import Cube networks that are routable in Visum. We also set up some projection system for Visum so that background maps display properly. We'll go over some Esri shapefile I/O where we import shapefiles for both Visum data in the zone layers as well as some point of interest data, which is how Visum stores generic shape layers. Then we'll also discuss something about the data interface with databases, Access, SQLite, GDB, and so forth. So with that, let's have a look at the Cube interface in Visum. So here I have a Visum started already. I have some Cube files batched out over here, and those can be then imported from the Cube import add-in. Let's have a look at what files I've batched out for Cube. Over here, I have this net file sitting for the Olympus training model. You can see that there are some files for the nodes, links, and then the lin file for your transit lines. Let's have a look at how this Cube importer works. We'll go for scripts, Visum add-in, import, and then import Cube network. This brings up the interface for the Cube importer. Then we go here and point to the file that we need. Here we have third-party Cube import net file. You can see over here that we need files for the nodes as well as the links. So first we select the nodes file and then click open. And this reads in all of the attributes attached to that node file. The node number is starting with or using the field N, so we keep that over here. In this field, we specify how we'd like to identify node from zones. As you can see in Visum, we store zones as a separate data object compared to nodes, and this is part of the overall data structure difference between, let's say, Cube and Visum. So here in this particular model, I know that maximum node number for zone is 653, so I can just enter that. On the other hand, if you have a flag, you can select use attribute flag and then select the attribute that identifies the node as a TAZ centroid, and the importer will interpret that data accordingly. So maximum number for zone 653. Next, we select our links file. So this is our link shape file. Click open. This again brings up all the fields in that link shape file. Over here, we need to select the from node number and to node number, which in Cube typically is the A node and the B node. So this number is set properly already. Over here, we go for B node. And that's the basic input you need for this cube importer to import a network into Visum. You'll see a couple of more optional items over here. So if you have a cube turn penalty file, you can select that pen file over here, and that'll bring in the turn prohibitions and such. The other one is the transit or lin file. In lin files, we've noticed that there are different formats for cube import. So some could be your old tran plan format and then the new PT format and so forth. So sometimes this importer may not work because it's structured to work, let's say, with the old format. For that, we have a different interface which allows you to still bring in those lin files with automated data batching. We'll cover both of these topics as part of the exercise that we show for file data batching using text files, so you have an idea of how to incrementally import network objects into Visum. So with this setting, we just click OK, and the importer churns through all of the data in those shape files and processes it to bring in a Visum network like this. So now you can see all of the nodes and links created over here. Typically, when cube networks are imported or third-party networks are imported, we'll append an IMPT before the original attribute name of that particular field. So let's say we have over here links. If you look at user-defined attributes, we can see that the original attributes are prefixed with a IMPT, and then the attribute name is copied over to Visum. This way you can keep in touch with like what you had in the original network and then keep track of it going forward with your converted network. Now, this network is imported without a projection definition, and that's why the background map is missing over here. So if we want to have a background map over here, we must define a projection system. In this case, I know that the projection system for this network is a state plane West Florida, and I can set that by going to network and then network settings, select the projection system from file. Over here, we have two sets of projection systems. In this case, we have the projected coordinate system, and that's under the state plane, NAD 83, and then I select over here, West Florida. And I click OK. We don't have to transform any coordinates over here because we don't have any base system to transform from. But let's say you had a different coordinate system, then you would let this box checked so that, let's say, you were transforming from a world system to another state plane system, the network coordinates will be transformed using the correct affine coordinates. So we just check this off and then we click all right. Okay. Now you can see that the background map is enabled. I can go and show my base map over here with my saved graphic. Over here, you can see now that all of the zone centroids are imported and shown in this green dots. And then all of the nodes are separated from those and the links. This particular network didn't have a connector setup. If you want to create connectors, there are some automated utilities in Visum that allow you to do that, where you can select connectors, right click, and then select create. Then you can define a criteria for defining these connectors or generating these connectors. You can generate connectors separately for auto and transit. So in this case, let's have a look at an example of generating auto connectors. So maximum distance or snap distance is 1 mile, and then how many connectors you want to generate, and then the maximum total if there are already existing connectors in the network. So I click OK, and then turn on the connector layer, and you can see some of the connectors are automatically generated. Now, some of these connectors are still missing over here, and that's because the search criteria did not return the less than 1 mile distance over here, in which case you can complete those connectors manually by going to the insert mode, connectors, connector to node, and so forth. So this is the general process of bringing in the Cube network and cleaning up some of the nodes, links, and connectors. Next, we want some shape data imported into this network. This would be for the zone polygons, because at the moment, as you can see, we only have the centroids defined, but we don't have any zone polygons defined in this network. So we can bring those zone polygons in using the shapefile interface. We can go for File, Import, Shapefile, and then go to my store of shapefiles over here. I pick the shapefile for zone data and then click Open. So here you can see that there's an option for reading this additively, which means that we can find a key for a zone number and then replace the boundaries over there to bring in these polygons. So I select read additionally or read additively, replace the boundaries. I'm going to read these as zones, and the lookup column for the zone number over here is zone. So once we have these settings and then click OK, we can see that we have now polygons in this network for the zones. So here, as you select the zone, you'll also see the polygon selected for that zone. There's another way to interface with shapefiles in Visum, and that's using the point of interest categories. And this is more of a generic object which we allow for import of shapefiles, which may not be used necessarily, let's say, in the modeling process for routing and so forth, but it's still useful data to have to look at or aggregate from. Let's say you're aggregating up data from census files, census tracts, block groups, and so forth, or some other data that you may have from, let's say, mobile OD sources and such. You can house all of that information inside these POIs. So the way to go about this is, first we create a placeholder to hold those POIs. So let's go for network and then POI categories, and then click create a POI category over here. I have some data sitting over here for these stops, and I want to bring these stops in as points of interest. So here I'm just going to say transit stops and generate this POI folder. Now I can read the shapefile into this user generated POI layer. So I close out of this, then I go back to File, Import, Shapefile, and scroll over to Shapefiles, Stops, select the stops file, and then click Open. Now in this case, we want to read this additionally, but we don't want to read these as nodes. So what we do is we point this to the POI and then point it again to the layer for the POI that we just created, which is for these transit stops. And then click OK. In this case, the POI layer does not have a projection file attached to it. So Visum will ask you if you want to associate a projection file with it. This POI layer or this transit stop point of interest shapefile happens to be in the same system as the base network over here. So we can just read it untransformed and it'll line up with this network. We can generate a user-defined attribute, which is the stop node ID, and then click OK. So over here, we can see that a bunch of point of interest are imported. Let's have a closer look at that. with the stops POI map. So here you can see that all of these points of interest can be explored through this POI editor. So this is a general format of working with shapefiles in Visum and importing existing cube or other networks into Visum. The next part we look at is the network import-export through text files. Let's have an overview of this process. Visum net files are essentially structured tables in a text format. So basically not very different from some of the other packages that you might be used to using. It's useful typically for bulk import and batching of data or merging data from different data sources. For example, over here in the image, you can see a little non-motorized or pedestrian type of network that's merged in with another network which is all auto and street oriented. So this way, if you have different data sources, you can use this net file interface to batch in data and apply different types of conflict handling rules to import this data into an existing base file. You can see that the structure of this has a few flags on top and then some column names over here, and then the data that you want to import. Let's have a closer look at this net file. You can go for network transfer. Then take a look at this net folder over here. Over here, we have a utility for batching the new format of QPT lines. And if you like this script, you can email us and we can send you the script for making your batching process easier with the cube lin files and such. So over here, once the cube file is batched into a Visum readable net file, it looks like this. You can see that the structure is kind of similar, but a little bit split up into different tables over here. So here we have all of these line names. Then we have all of the line route names by direction. Then we have each of these items running over the nodes. So with this structure, we can now import this net file back into Visum. Let's go back to the Visum network, turn off this POI layer. To import a net file, you can simply go to the net file and drag and drop that net file, or go for File, Open File and Network, and select your net file from here. So I select this PT network, click Open, and now it shows me a few options for completing line routes, as well as the flag for reading this network additively, which means that we are batching this network on top of an existing network. So we select this line route completion. Over here, we get some options for conflict handling for the import. So let's say there is data already in your network which might conflict with data in that net file. You can set up different conflict handling rules of whether you want to update, override objects, or ignore the conflicts, in which case that particular data which conflicts with an existing data in Visum will not be imported or skipped. So here, I just keep the default conflict handling and then click OK. Here I get some options for completing line routes. So over here, even if your line routes are not 100% aligned with the node identifiers in the target network, you can apply some rules in Visum to find the most likely link sequence over which the transit line would run. So there are some built-in data completion options already available for batching some of these line networks into Visum. So here we'll ask it to create stop points where it finds the nodes with stop points, and then open the transport system for that particular stop point. And then we also ask it to use closed route links for routing because we haven't defined a transport system that can be used for running over that network object. We have two transport systems over here. So 2131, which is the bus and project bus. We apply this same rule to both of them and then go for next. Over here, as the line is being built, Visum is giving you a message of warning that certain turns must be opened up for this particular transport system and so forth, for which in this case, that's all right, not a critical issue. We want the turns to be open. So we click this and then go ahead. And then it's the same warning repeated over here for each of those line routes. So say yes for all. And this way, all of the lines are batched into this network. Let's take a look at that. So here we can see all of the stops and the lines batched into Visum. All of the stops are placed in this triangular graphic, and then the two different lines based on whether it's a 21 or 31 transport mode is blue or red. So this way you can batch in lines and PT networks into Visum. You can examine this more closely over here and so forth. So this is the general interface for line route batching. In this case, we didn't have any conflicts with the base network or any special handling for the objects that we imported. But in some cases, you probably want to have the objects modified in the target network. Some example of this could be this turn penalty file. So let's say we want to bring in these turn penalties. This is the base turn penalty file over here, the raw file from, let's say, Cube. This can be transferred into a Visum net file, which is a similar format, but just with some different headers. So we specify from node, via node, to node, and the tsys set. Now, tsys set in Visum is a text-based definition, and you can input the modes open for the turns using the text identifier used for that mode in a comma-separated format. This is a little bit different from Cube, where Cube will use the flag for 0 and so forth for which transport system you want to ban from turning, and then an explicit flag for banning those turns or applying a penalty. Over here, we want to close all of those turns because they're all -1. So we just enter a blank over here and then patch this file back into Visum. So let's go back to Visum. I'll go back to File, Import, File, Import, and then open File Network, Turn Penalty, and then I click this to open. We don't need any line completion items over here, so we check this off this time and then click OK. Over here, there's a difference this time that we are reading the turns in, but we want to overwrite the attributes in that if the turns are open, we want to close those turns. So we say overwrite attributes and then click all right. That batches in the turns. And now you can have a look at the turns in the turn listing and see that some of the turns that were banned in this file over here will be closed over here as well. So let's go for one of these turns and see what happened to that. So I'll filter by via node. And you can see different turn combinations over here. And you can juxtapose this with which turns were blocked. So 5250, this particular turn It's blocked, and you can see over here that over here it's also blocked for the transport system. So this way you can batch files in two different ways. Over here you can either read it without any conflicts and ignore conflicts, or you can apply your conflict handling rules to update existing data within Visum. So this is one way of doing file batching in Visum or networks. So we saw that over here we can either override or update attributes, and then it also offers some line completion or network completion options. Next, we look at another data batching format available in Visum. We call it the TRA or TRA transfer file. Transfer file is again a structured table in text file with some special flags which allow a little bit more than the network files or net files. So in this table, you can see over here that we have this plus, star, and then remove flags or minus flags. So based on the flag defined over here in this table, Visum will treat those objects differently. So if you have a modification flag, Visum will modify those objects. A plus means you're adding new objects, and remove means you're removing some links or nodes from the network. So to work through this example, we'll show you a working example through first importing a GTFS network and then adding some edits or modifications to it. And then that will create a scenario of a line build, and then exporting that GTFS network into a GTFS format from Visum. So let's go back to Visum, and then I'm going to clear this old network over here. Now I go and set my project directory to where the GTFS data is stored. So edit project, open GTFS networks, click all right, okay. Now to import the GTFS network, again, I go back to file, project directories. We've already set this project directory to GTFS. So then we go for import GTFS. I have a GTFS file stored for Sun Transit or Sunrail, because those are the typical networks that you might edit, let's say with stops. So I look at this Sunrail GTFS feed, click open. I have some parameters stored for this import already, which is GTFS import parameters. And this just sets all of these checkboxes and so forth to what they were. So let's say you were looking at different options for importing and wanted to store these parameters. You can set these options and save the parameter file. That way you can replicate the same parameters while importing other networks. So I basically applied a date filter over here and then added some more options over here before I import this network. Then I select OK. And that imports the Sunrail network over here. So let's go over what we want to do over here next with this description over here. So what we are trying to do or mimic over here is, let's say, a workflow that you might have for GTFS editing for FTA stops program. So the first step that we did over here was to import the GTFS line into Visum. Then what you would do is, let's say, add your new build, new service with a timetable, and then export that back. Over here, we have already an airport. And let's say, for example, you wanted to add or evaluate a new line to and from the airport. You can add that over here in this network now, generate the timetable, and then export all of that data back to GTFS format so you can analyze it in stops. So here, what we basically do now is to create a node so that you have a node for the line network. Then you can select a link, and let's say you want a direct line to pass through and connect to the CBD node over here. Click OK, and then you can add a new line. This is a rail line, let's say Airport Express, and so forth. So this is the general workflow of your line editing. We'll have a look at more detailed line editing in our network editing exercises, but the workflow over here now involves application for that transfer file where you can make these kind of edits, and then once you've made these edits, store this data into a transfer file. So you can go for compare and transfer networks and select create model transfer, and then store these edits into a transfer file. Let's see what one of these transfer files looks like. Open this in a text editor. So you can see over here that I've created this transfer file earlier for converting this base network to a network with a new line, and we add a bunch of new fields in it. We add some nodes in it, stops, and then we also add some timetable and time profile items over here. These vehicle journeys in Visum correspond to the trips that you see in the GTFS format. So we've added a bunch of vehicle journeys for the new services over here. Now this model transfer file can be applied directly to this network over here. Let's see how we can do that. So you can go for File, and then Compare and Transfer. You can say Apply Model Transfer, and then have a look at that new network file. So let me get rid of first this information over here, and then apply the transfer file from scratch. So we can go for File, Compare and Transfer Networks, Apply Model Transfer File, select that transfer file over here, and click Open. And then click through all of the conflict handling and so forth, which in case of a transfer file, basically since the conflict handling is specified in the flags with the file itself, you can click through it without making any edits to it. So once you apply your transfer file, you can see that over here, this new line is added, and this new line also now has a timetable attached to it. So here we have the Airport Express to and from the airport. You can select one of these services and look at the new timetable for it. This timetable for the line can be auto-generated in Visum, where you would just basically create a new vehicle journey, select regular services, and let's say you had an idea of the headway. You can say select regular services, define the time period for the headway start and end, and the frequency of the line, and this will auto-generate this timetable for you. So it's a very convenient tool to use if you're doing I/O with GTFS formats for analysis of your projects in stops and such. So once this line is built, we can export this to stops or the GTFS format for use in stops. To export this line in GTFS, you can go for File, Export, and then General Transit Feed or GTFS. Select your export directory. Here I'm just going to store it in the GTFS folder. You can apply the mode over here. Over here is the mode number 2, which is rail in GTFS. You can specify a URL for the agency and so forth. This information you can typically obtain from the GTFS file agency data. So let's say I look at this agency data over here. I can just copy this URL from this agency data, input that over here, and the time zone again is available in this agency data file. So with this, I have all the options set. Then I can just click OK. And that exports the data out to GTFS. Now you can see that I've exported this network today over here. And then this one will have all of your data with the stop times, which is all of the vehicle journey details. Then you'll have all of your trips, which is the timetable that you defined, and the other information regarding routes and so forth. So we have the new AP Express route over here. Now you can use this data set with further analysis with FTA stops. Another important topic with models typically is matrix data exchange. Visum supports data exchange for various matrix formats. You can have matrix data either in Visum format, which is either a text file or Visum binary matrices. And then you can also interface with generic text files or CSV files that are delimited by some comma, semicolon, and so forth. This format or import format is usually applied to cases where you're importing these IMJV type file formats, or if you have mobile OD data which is provided to you as a CSV file with a zone ID mapping, or even XY data, you can import that information into Visum. We also support this open matrix format with OMX files, which you might have if you have activity-based models and such. Over here in the specification for the OMX files, you have to have two tables in the OMX file. One is the data folder, and then the other one's the lookup folder. We've noticed that sometimes this lookup folder is missing from some files, especially if you exported data or an OMX file out of Cube, you might have this lookup folder missing, in which case it might be easier to also import this data with this H5 file library, which interfaces with HDF5 type file objects, and you can find information on this. We have also a template script for importing this kind of generic HDF data, and again, you can email us to obtain that template so you can get an HDF type import, which is non-standard to the specification here. Let's take a look at how these file imports work in Visum. And go back to Visum. I'll change my working folder now. Go back to the matrix interface and then select my file for matrix interface. Let's use this base version file over here. All right, so we have a file loaded over here with some matrices. Now let's look at how this matrix interface works in Visum. You'll typically have a whole set of procedures for calculations and so forth. And then at the end, you might have some data batching steps. So this over here is a group created for matrix IO. We show different matrix formats over here. So one of the common formats is a simple Visum matrix, which you can insert in this procedure calculations. We'll go over these procedure calculations also in more detail in one of our upcoming sessions. But over here, we just define the workflow for these matrix IO operations. So we just select the save matrix function. Then we select what format that's going to be. And Visum supports different formats for its own matrix export. So you can export a binary matrix or an O format, which is kind of the OD format, or a sparsified IJV file and such. Then you specify the matrix name that you want to use for the export, and then you can just simply run this process to export that file. Now that exports the file out to the Visum matrix folder. Let's have a look at what pushed out. So here is a Visum matrix, and in this case I had a binary file, so we won't be able to make much sense out of it in a text editor, but that's basically your Visum exported binary file. Then we have also the OD import format that we discussed earlier. So in the OD import format, you can have a generic text delimited file. In this case, I have this IJV file, which I can load up in Visum based on some IDs. So in this IJV file, I have a from zone ID, to zone ID, which is sitting in the network over here, and then the number of trips in each of these OD pairs. So this file can be then referenced or accessed over here with the OD import interface. So I select this over here, then I go for edit to change the parameters. Now here I'm going to select the matrix file, the IJV file over here. Then you can either import this by coordinates. So let's say your from and to zone had XY data. You can select this and select the XY data corresponding to each of those zones. And this way it'll do a point and polygon test automatically and place all of the data in the correct zone based on the zone polygons. Over here, we are mapping by IDs. So we just look at the origin zone, destination zone, and the weight in this case would be trips. If there's segmentation in your data, you can add more data segmentation, or you can also add timestamps and such if you're importing data that has various different timestamps and times of day. This is a simple matrix, so I won't be selecting those options over here. Then I select OK. And then you simply run the OD import. And then you can have a look over here that the matrix data gets imported in all the way at the end. So this creates a new OD matrix with a new key, and you can then have a look at this data with the usual matrix editor. One more option over here is to import the data into an existing matrix or update an existing matrix. In that case, you can go over here and select the ID fields and import that data into an existing matrix. Next, we look at the OMX exporter import. So let's have a look at this OMX export first. So again, we create the OMX import process from the procedure sequence or procedure options. Select the procedure step and click edit. We can change these parameters over here. Over here, you can define which object you want to export. So you can export at the level of zone, main zone, which would be your districts, and then stop areas if you have a stop area to stop area flow matrix. You can use a reference for selecting the matrix. Then you can go for check, and it returns this external to external trip table. And then some matrix metadata. By default, Visum adds these metadata items to export to OMX. If you have a lookup table that indexes based on something other than the zone number, you can change that over here. The default that we use for indexing or generating the lookup table with Visum is the zone number. So with these settings, you can click OK and then export the OMX file. And then that OMX file generates this EE trips OMX data. Now, if you wanted to import this data back into Visum, similarly, you would use the OMX import step, which is another option in the procedure sequence. Select this, select edit to change the parameters of the import. Select your OMX file over here. The object type reference, in this case, it's related to zone, so we select zone. And then the lookup table, and then the zone attribute used to match or index the matrix. Here you can create either a new matrix again, or you can overwrite an existing matrix. So we click OK and add a new matrix in this network, and then run this step. So now you can see over here that the EE trips matrix is also added. So it's the same matrix as the previous OD matrix, but stored in a different format, which is this OMX format. So this in general is the workflow for matrix data exchange in Visum. Next, we have a look at some other miscellaneous items, such as subarea extraction and export, which might be useful to you. So subarea extraction and export is a point and click operation in Visum. You can select the subarea in a network based on either a freehand polygon, or you can use a shapefile and then select data within that polygon shape to generate your subarea selection. The typical application for subarea exports for us has been exporting the data to microsimulation or some smaller subarea models for simulation-based assignment and such. So let's have a look at what comes out of the subarea export. The more important thing that you need typically from the subarea export is the traversal matrix or the cordon flow matrix that you can then use to assign in the network. So the workflow for the subarea network import or export in this case is, so we have our general network setup over here. In this network, I've set up a territory. Let's zoom in closer to that and see what that's like. So this little sub network or sub area is going to be exported to a smaller network. What I have in this particular network is an assigned flow, which is basically a traffic assignment with path storage turned on. So this path storage is then used to automatically generate this cordon flow in this sub area. So with this territory, let's select this territory in for the sub area export. So we'll go to spatial selection. We'll go for mark objects in this territory and then select this territory. So this picks this particular sub area focus, and now we can export this sub area into another file and have a look at the cordon flow matrix. So for exporting the subarea, next we go for calculate, and then subnetwork generator. Let's select a subarea folder over here. Subarea. Now over here we have different options for line route export, and then different options for which cordon flow matrices you'd like. In this case, we'll stick with this default of cutting the line route off where only the cordon stops in the subarea are selected. Then over here, we'll select all of these matrices for cordon flows. So the multi-class flows are exported as is for the subarea. You can select a numbering scheme over here for how you'd like to number those cordon zones. So when you look at your subarea network, you know which one is a cordon zone generated by Visum and which one was the original zone that was already in your network. The connectors can also be named or typed based on what type of connector it is. With this, we can just click OK, and the program will process all of this data and the past data and give you a subnetwork with cordon flows. So now I can open my subarea over here. So this is my subarea focus. Let me select all of these objects over here. Then you can see some links are still exported. And this is because of the options that we selected for the transit lines. And in this case, it keeps all of the links that are necessary to have that transit line matrix intact. In some of the other options, it would cut off all of those transit line flows and not keep these nodes. Let's look at the matrices over here. So all of these are now the matrices for all of the cordon flows. So you can see all of these matrices are generated with some new cordon zone numbers over here and the corresponding flows in and out of that subarea. So all of these cordon flows are then generated in Visum for all of the subarea relations. So this completes the subarea export from Visum. Another interface that we have that may be of some use to you if you're using the activity-based models is the ABM interface. At the moment, we've just implemented this as a script solution because the ABM data structures are still evolving and we want to be adaptable to import various different types of ABM. So here we have essentially a few custom Python scripts, which again, we can share with you if you're working with some ABM data imports. But the gist of it is that we have different functionality in Visum over here to add this activity locations, households, persons, schedules, and so forth. And these are generated using the data from the synthetic population over here, and then the output that comes from your ABM model. In this case, it's a CT ramp model, and then we import the individual and joint trip and tour data and create a mapping between the Visum objects that hold the ABMs and link those with all of the disaggregate points here. So once the import is completed, it looks like the following over here. Now here you can have a look at each of these disaggregate activities that came from the ABM at the activity execution or the tour level or even at the different trip level.